Welcome to The Explainer. Today, we're diving into a single research paper from 2017 that pretty much set the stage for the entire AI boom we're seeing right now. It's titled Attention is All You Need, and honestly, it's the blueprint for how modern AI works.
So let's start with the big question, right? How can an AI like ChatGPT seem to actually understand what we're asking it? You could throw a complex sentence at it and it just gets it. Well, the answer lies in a huge shift in how these models read, a total revolution that started with this paper.
You see, to really get why this was such a breakthrough, you gotta understand the old way of doing things. For the longest time, language AIs were stuck. They had to read sequentially. Imagine trying to read a sentence, but you can only see one word at a time in a strict order. That was the huge handicap they were dealing with. And this created what we call the sequential bottleneck. Before 2017, the top models were called recurrent neural networks, or RNNs for short, and they were completely trapped by this one word at a time way of thinking. So think of an RNN like it's reading a really long scroll. It reads the first word, gets a little bit of context. It reads the second word and adds that to its understanding. It's this long chain where the context is passed down step by step, word by word. Now, this one-by-one process, it was a huge problem. For one, it was incredibly slow. You can't process word number 100 until you've done words 1 through 99. So you couldn't use powerful parallel computers to speed things up. And maybe worst of all, by the time the model got to the end of a long paragraph, it had basically forgotten the important stuff from the beginning. And this chart from the paper just makes it crystal clear. With the old recurrent way, the number of steps the computer had to take, this O of n, grew with every word in the sentence. But with the new way, self-attention, it's O of 1. That means it's a constant number of steps. It doesn't matter if the sentence is 10 words or 1,000 words long. It creates a direct connection between every single word, all at once. So how do you escape that one word at a time prison? Well, this is the paper's Eureka moment. It's an idea that seems simple in hindsight, but it's incredibly powerful. It's called self-attention. The authors had this brilliant insight. They thought, what if we just throw out the whole sequential process? What if we let the model look at all the words in a sentence at the exact same time and let it figure out for itself which words are important to which other words, no matter how far apart they are? What this means, really, is that for every word, the model can pay attention to all the other words to figure out the real context. So in a sentence like, the dog didn't cross the road because it was too tired, self-attention is what helps the AI know that it refers to the dog, not the road. It's a superpower for understanding context. So, armed with this incredible self-attention mechanism, the team at Google proposed a totally new kind of AI architecture. It threw out all the old rules about processing things in order, and they built it from the ground up on this one idea. They called it the transformer. Okay, I know this diagram looks a little intimidating, but the core idea is actually pretty elegant. It's basically two halves. On the left, you've got the encoder. Its job is to read and understand the text you give it. And on the right, you've got the decoder, which takes that understanding and uses it to generate something new, like a translation. And both of these halves, the encoder and decoder, are just stacks of identical layers. And inside every single one of those layers is that powerful self-attention mechanism, looking at all the data in parallel, not in sequence. This is the engine that drives the whole thing. But they didn't stop there. They realized that having just one attention mechanism is kind of like having only one person read a sentence. They might focus on the grammar, but miss the deeper meaning. So they asked a really smart question. What if we could have the model read the same sentence from a bunch of different perspectives, all at the same time? And the solution was just brilliant. It's called MultiHead Attention. It's literally like having a team of experts read a sentence simultaneously. You have one head that's a grammar specialist. Another head looks for the overall theme. A third one tracks pronouns. The paper used 8 of these heads, all running in parallel, giving the model this incredibly deep, layered understanding of the text. So you have this amazing new theory, a complete paradigm shift in how to think about language. But the real question is, did it actually work? Well, this is where the story gets really exciting. The team tested the transformer on the super difficult task of machine translation. For this test, a higher score, the blue score, is better. As you can see, the other models were all kind of clumped together. The transformer didn't just beat them. It left them in the dust, setting a brand new record by a huge margin. Now, a jump of over 2 full points might not sound like a lot, but believe me, in this field, that is an absolutely massive leap. This wasn't just a little improvement, this was a whole new ballgame. And here's the real kicker. It got these amazing results while costing way less to train. Because it could process everything in parallel, it needed just a fraction of the computing power that the older, clunkier models needed. So it was better, faster, and cheaper. That's the trifecta. And when you have something that's better, faster, and cheaper all at once, you don't just get a new piece of tech. You spark a revolution, and that is exactly what happened here. The bottom line is this. The transformer architecture is the engine inside pretty much every single large language model you've heard of. ChatGPT, Gemini, Claude, they all have the transformer's DNA inside them. It made training these huge models possible, and that unlocked the entire AI world we live in today. Reading their conclusion now is pretty incredible. You can tell the authors knew they had something big on their hands. But looking back, this sentence has to be one of the biggest understatements in the entire history of computer science. By breaking AI out of that one-word-at-a-time prison, the transformer unlocked the door to the creative, powerful, and sometimes surprising models we have today. It solved the sequential problem, which leaves all of us with a really fascinating question to ponder. What's the next great bottleneck for AI? And what brilliant, simple idea is going to be the one to break through it?